Now, we're also required to be able to conduct a hypothesis test based on the product moment correlation coefficient. So if you remember, the product moment correlation coefficient, the value of R, is a value between -1 and 1, and it tells you how correlated your data is. So the closer it is to +1, the closer it is to perfect positive correlation. The closer it is to -1, the closer it is to perfect negative correlation. Now, let's say that you've got your data, your bivariate data, which just means two variable data, and you've plotted it on a scatter graph, okay? And let's say these might be the heights and weights of 12-year-olds, okay? And you've plotted your data. And what you want to do is you want to conduct a test to determine whether what you found is correlated enough to suggest that there is a correlation, in this case a positive correlation, between the two variables of the whole population. Okay, so obviously you can't go out and measure all the heights and weights of all the 12-year-olds in the country. Okay, you can't do that. So all that you've done is you've picked out a small sample of these, and you're wanting to determine whether you have enough evidence to suggest that the whole population will be positively correlated. Okay? Now, clearly, the more points you have, the larger the sample, the better the picture will get. Okay? So how do we actually go about performing this hypothesis test? Well, the first thing you would need to have is a value of R, okay, which perhaps for this is, I don't know, 0.8. Okay? Now, remember, for this course, you are not expected to calculate the value of R. Okay, so the value of R would be given to you. So that's okay. So then how do we perform the hypothesis test? Well, the first thing that we need to introduce is the population correlation coefficient. And that is the value of R, effectively, for the whole population. So we're going to give that a specific letter. So we're going to say that let rho, so this is a Greek letter rho, let rho be the population correlation coefficient. Okay? So this represents how correlated the whole population is. The null hypothesis that we start from for these hypothesis tests is to say, well, let's play devil's advocate and say that there is no correlation at all. So we say that rho is 0. Okay? Then H1 is either talking about, well, we think the alternative is that there is a positive correlation, or it could be that there is a negative correlation, or that we think there is some correlation, so it's not equal to 0. And that brings about the two-tail test. So both of these would be one tail, that would be two tail. Okay? So then, what would happen next? Well, then you would have your sample, okay? So the sample size here is 1, 2, 3, 4, 5, 6, 7, 8, okay? So sample size here is n is 8. And let's say that there is a 5% significance level, okay? So now you would need to have a value, the critical value, that is given by that data, that information. Now, depending on the exam board that you're using, you may or may not have a set of the statistical tables. Now, it won't look exactly like this because this is from the old spec, okay? But you will have some tables based on this. Now, if you're doing it Excel, for example, you will have tables, a set of statistical tables, and one of them will be the product moment correlation coefficient tables where you could look that value up. AQA, however, for example, doesn't have any statistical tables with it. And so if for AQA, if you were asked this question, you would be given the critical value as part of the question. So the critical value that you would be given at a 5% level for n is 8 would be 0.6215. So the critical value is 0.6215. Okay? Now, if this was a two-tailed test, right, then we would have had to have halved the 5% and looked at 2.5% from the tables, okay? I've just treated it as a one-tailed test, okay? So the critical value would be the 6.6215. Now, let's go with this one, okay, that rho is greater than 0. Now, you know that R ranges between -1 and 1, with 0 in the middle, okay? The critical value that's been set there is 0.6215. 0.6215. So this is your critical region. 0.8 is clearly inside your critical region, and so it is significant. So you would have to say that 0.8 is larger than the 0.6215. So the result is significant, and so you can reject H0, and so there is evidence to suggest that the two variables, now you'd have to write that in context, so the two variables are positively correlated. Okay? So that is how you would complete this test. Now, let's say, for argument's sake, that we have that rho was less than 0. Let's say rather than the R is 0.8, let's say we had minus 0.8. Okay? Now, the critical value from the tables would still have been 0.6215. Okay? But it is nonsensical to compare that critical region with minus 0.8, which is down here. Okay? So what you would instead do is that the critical value works in both ends. So this is the same as saying, well, we're looking at minus 0.6215, and this is my critical region, and the minus 0.8 is here, which is in the critical region. So you can make it positive or negative depending on whether you're looking at positive correlation or negative correlation. So that is the structure, and we're going to go through a few examples in the next few videos.